All right, here's our lesson. We've got two today, 7.2 and 7.3. So first we're going to talk about isosceles and equilateral triangles. And what I've got for you here is just kind of a basic summary of all the different ways to classify triangles. So the first four are ways to classify triangles just by their angle measures alone. So if we look at just these top four, by definition, and you need to know all these, equilateral have all equal angles. And I didn't even say that right, equiangular, that's what that means, all the angles are equal. And if all the angles in a triangle add to be 180 degrees, then all the measures in an equiangular triangle are all going to be 60 degrees here on the inside, because that's how they're all the same. An acute triangle just means all three angles are acute. A right triangle is going to have one right angle. And then think, if these have to add to 180, then these other two angles are always going to be acute in a right triangle. And then an obtuse triangle has one obtuse angle. And hopefully you realize, because they have to add to 180, it's not possible to have more than one obtuse angle in an obtuse triangle, or in any triangle for that matter. Because if you have more than one obtuse angle, you're going to end up getting a triangle that's bigger than 180 degrees, which isn't going to form correctly. All right, and then equiangular, so the top four are all ways to classify by angles. These bottom four down here are all ways to classify by sides. So equilateral means that all the sides are equal. So notice that one is equiangular, the other one is equilateral. Lat is another way to say sides. All right, and then isosceles has, notice this definition, at least two sides that are congruent. And then scalene, no sides that are congruent. So how we would mark the scalene triangle, you might have like 1, 2, and then 3 here. And that would just indicate to you that all three sides are a different size. Now there are some special relationships between isosceles and equilateral triangles that we want to talk about. So an isosceles triangle, if I go ahead and draw that out for us, we've got some vocabulary that we need to know. All right, so isosceles triangles are going to have two legs. So the legs are the sides that are congruent to one another. The vertex of an isosceles triangle, all triangles have three vertices, but when we talk about the vertex of an isosceles, we're talking about this point in between the two legs, so the angle that is in between these two congruent legs, and then the bottom is called the base. And these base, what we call them base angles, are these two that are at the bottom. So some things to point out, some different properties, and there's really just one different property. I want you to notice, and you should write this in your notes, that the base angles are not only congruent to each other, so notice that I marked those to be congruent, but also they are the ones that are across from the legs. So when I'm looking opposite through the triangle, I'm going to notice that base angles are across from their legs and they are congruent. All right, so those are our notes for isosceles. So equilateral, if we go ahead and draw our equilateral out, and we already kind of talked about this a little bit, equilateral means all the sides are equal to one another. But equilateral and equiangular are going to go together. So that means not only are the sides congruent, but think the angles across from them must also be congruent. So that's going to give me that I have an equiangular triangle also, and that all of these angles are going to be 60 degrees. Okay, so once you have all that in your notes, let's move on and try two problems together. All right, so this first one, you are probably going to want to have this drawn in your notes. Notice this first one is marked as an isosceles triangle. They're showing me that I've got two legs here that are congruent. Now the angles opposite those legs are going to be equal, so I know that angle P is going to be congruent to angle Q. Now, they're asking me, the problem is they don't give me P, they give me this R up here. However, because I know those are congruent, I can mark angle P to be 3x plus 3. And I know that all three angles in a triangle add to equal 180. So if I write this sum up, 3x plus 3 for P, plus 3x plus 3 for Q, plus 5x minus 2 for R, I know I'm going to get 180. Now, if we go ahead and work out the algebra there. So pause the video and work out that algebra for a minute. All right, I'm going to get the x equals 16, and obviously to find angle P, I'm going to need to plug that back in. However, no matter what it's asking, it's always wise for you to plug back in just to check. So if I plug that back in, I think I should be getting, let's see, that's 48 plus 3, 51 and 51. And at the bottom, that's 80 minus 2, so that's going to be 78. So I do verify that all three of those do add to equal 180. And then also, and we're not really talking about this, but just so you know, if they asked you to classify this triangle, this would be an acute isosceles triangle, because all of the angles are less than 180 degrees, or sorry, less than 90 degrees, and then isosceles because two of the angle measures are congruent, as well as two of the legs. All right, so let's look at our second example. All right, so our second example here says that she's trying to get an emblem made that has an equilateral triangle. And she's given the t-shirt company something with these dimensions. So we want to know what the length of each side of the triangle is. So let's kind of zoom in here. Even if they hadn't said equilateral to you, you would know that these were equilateral because it marks that all three angles are congruent to one another, which means I know all three sides must be congruent to one another. So if I go ahead and set this up, I can set up that AB, which is 3/10 y plus 9, is equal to AC, 4/5 y minus 1. Now, you and I have not solved fractional problems together, and I'm not really concerned about you all knowing how to solve fractions. However, I personally do not like fractions, and I do everything I can to get rid of those before I start. I see that the least common denominator here is 10, so I'm going to multiply everything by 10 just to eliminate my denominators. So that's going to give me 3y plus 90 equals 8y, because that's 40 divided by 5, which is 8, minus 10. All right, and then I can just solve the algebra from there. 5y is going to equal 100, so y is going to equal 20. And then again, we want to go back and plug this in to find the missing side lengths. So either place that we plug it in, we should get the same thing. So 4/5 times 20 minus 1. I don't know if you remember your fraction rules, but these 5 and 20 kind of cancel to give you 4 and 1. So that's 16 minus 1, which is 15. And you would get the same value if you plugged it on the other side. If we didn't talk about that fraction stuff tomorrow, we certainly can. But I hope that if nothing else, you understand why you're setting the two of these equal to each other in the first place. All right, now we've got one last property to talk about, and that's inequalities in one triangle. We are going to talk about another property in class tomorrow that we will add to your notes, so make sure you kind of leave some space there, or we can add them on a separate piece of paper if we need to. This inequality talks about the size relationship between different sides and angles. So what I have drawn for us here is a right triangle. And the reason is because you already know some things about right triangles. So one of the things you know is that this side opposite of the right angle is called the hypotenuse. And many of you know that the hypotenuse is the longest side. And what I want to talk to you about is how we know that that's the longest. And if you think about the relationship between angles, so everything we're talking about today is how we relate angles to their opposing sides. So the angle here is 90 degrees, and I hope that you agree that 90 degrees is the biggest angle in any right triangle, because the other two have to be less than that, or else the triangle won't add to give you 180 degrees. So the biggest angle, which is 90, ends up being across from the longest side. All right, so that's one of our relationships. All right, and then the converse of that is also true. So if the largest side is across from the longest, and I said that backwards, if the largest angle is across from the longest side, where would you think you would find the smallest angle? And hopefully what you're coming up with is that the smallest angle is across from the shortest side. All right, so if you know those properties from today about equilateral triangles, isosceles triangles, and these inequalities in one triangle, you're going to be in a really, really good place for tomorrow. Like I said, we're going to add one more property, but it's going to be a pretty kind of a pretty fun one for us to figure out together. And then we'll spend a lot of our class time tomorrow really just working through and applying some of these properties.